Hello guys, welcome to Prof. 1 YT, and I really appreciate your subscription. Thank you very much. So today's video is on calculus, that is continuation with first order differential equation. So we're going to take some examples and solve using the general and the particular solution. Yeah, so today's video will not be done by Prof. 1. I have a special guest here who's going to do this video for me, and she's very, I don't know how to mention intellectual, very, I don't know, you hear from her. So hello, what's your name?
I'm Francis.
Francis, very nice name. So her name is Francis, and I know that you've not heard it before, as I've not heard it before. So Francis, take over.
Thank you so much, Prof, for this opportunity. Hello guys. So today we are going to be doing solved examples under first order differential equations. The first thing that I want you to know is that there are a lot of methods that you can use when you are solving first order differential equation. But it depends, okay? The solution that you can use depends on how the arrangement of the questions are. So let's not waste time. Let's get right in the homogeneous method. So that one, you have to identify if the question you are given is homogeneous.
And how do you identify if a question is homogeneous?
That is when the power, okay, on both sides of the equation are the same.
So that means that they have the same degree, right?
Yes, please.
Thank you very much. Oh, that's very nice. That's very nice. Okay, so the question is here, so
yes.
we can continue.
But before we continue, there are a lot of ways, okay, of identifying if an equation is homogeneous. So that one, we'll talk about it in another video, so expect that.
Yeah.
So one thing about the homogeneous method is that we will do something, okay, we will substitute a certain equation into the question so that it can be easy for us to separate.
Very nice.
So in a way, the homogeneous is kind of a higher level than the separation, because when you are given the homogeneous, you have to try and substitute so that you can then separate. So let's continue. So what you are supposed to substitute. What you're supposed to substitute, we'll talk about it. But before that, let's change the y prime, okay, to dy ds so that we wouldn't get confused, right? Yes. So now let's talk about what we are going to substitute. You have to substitute what y equal to xv. Y equal to xv. And this expression, you have to also substitute other stuff into the equation, okay? So the simplest way of remembering all the substitutions is that the first one, remember y equal to xv. After that, differentiate y equals to xv. So you get dy equal to x dv plus v ds. So we had this because there is a multiplication of s and v. So you use, according to differentiation, right, the principle of multiplication when the product rule, yes, the product rule. So we are trying to make dy dx the subject.
So with this, we are trying to substitute in with the expression, that is, if you check this equation, it's the same equation here, as you know that xy prime is the same as x dy dx, and as we've substituted with y, which is xv here, so it's the same substitution here, and x. So this is the same equation for this, just that we've done some substitution.
Sure.
Let's continue. We can continue.
So as I said earlier, you have to substitute what we've talked about, that is the y equal to xv and its derivative, into the question that you are given. So after doing all that, we then arrived at s dy equal to dx into bracket vs plus x.
What we did here is that we try to cross multiply so that we can make, you are trying to move x to one side and v to one side.
Sure. So after substituting the things that you have to substitute, then you come to the method of what? Separation. So now we have reduced the equation to what? Separation variable. So we have to separate them. So we are separating the s from the y.
Yeah, very nice. But now we know that the dy has not been substituted. So now we are going to substitute in with the dy,
sure,
which is equal to s dv plus v dx.
Sure.
Yeah.
So at this stage, we are not having s and y's, but rather we are having s and v's.
X and v's. Yeah.
So
very
we
nice.
have to separate the s from the v's.
Yeah.
So let's do the separation well.
So when you do that, you're going to multiply through by x so that we eliminate this x
Sure.
from there, right?
Sure.
So when you do that correctly, this will cancel this, right?
Yes.
And this will be over. So when you do all the equation, and this s also will take care of what? This
The
x.
x.
So what you get here is this one.
Sure.
So now we try to make let's do something here. We try to expand this, expand it, and when you
Sure.
expand it, you're going to get s du s
The
dv plus v dx, which is
Sure.
equal to v dx plus dx. And as you can see, when you send this one here, this can take care of what?
Yes.
This,
Sure.
right? So at the end, you're going to get this.
Sure.
But with the x must go with the dx.
Yes.
So we try to divide through by 1 over x,
Yes.
and when you do that correctly, you're going to get what?
dv
dv is equal to
the s on s.
and that can be expressed as you find the integral. Yes, and when you find the integral of that, you know that when you find the integral, you're going to get v ln c plus v ln x plus c.
Sure.
That will give you the answer.
Sure.
Yeah. So I'm very happy that you did this video. How do you put down? Oh, yeah. Can you say something to our subscribers so they subscribe more and share our video?
Sure. You people are very lucky and blessed to have Prof solving wonderful questions with you people. So I would advise that you continue watching. And then those who have already subscribed, we thank you for your subscription.
Yeah,
those who are watching for the first time, we want you to subscribe because we have wonderful content for you, very educative.
Thank you very much. You're welcome.